In 1994, scientists around the world watched as pieces from a disintegrated comet smashed into Jupiter. This was a great opportunity for scientists to witness the collision of two celestial bodies. The collision of Jupiter and the comet fragments had been predicted after a team of astronomers identified the comet fragments a year earlier. Eugene Shoemaker, his wife Carolyn, and David H. Levy took photographs of the night sky in March of 1993. Carolyn Shoemaker noticed what she referred to as a squashed comet in one of the photographs. They contacted Jim Scotty at the Kitt Peak National Astronomical Observatory in Arizona, and he verified what they had observed. They were looking at fragments of a comet that on its last passage through this part of the solar system must have been torn apart. 20 large fragments impacted Jupiter at speeds of 30 miles per second. The largest fragments were over 1 mile in diameter and created disturbances in Jupiter's atmosphere that lasted for months. The results of the collisions will be studied for years, but one thing is very apparent. The fragments created quite a stir on Jupiter. One of the fragments made an explosion the size of the Earth. What is the likelihood that a similar collision could happen on Earth? Well, the answer is that it has. There is evidence all around the world that our planet has been hit by large asteroids and comets at various times throughout history. In fact, every single day, an average of 20 million pieces of space debris make contact with our atmosphere. 20 million is an awfully large number. When we scientists talk in terms of large numbers, we kind of forget that most people don't realize what a million or a billion really is. We say that the age of the Earth is 4.5 billion years, or the dinosaurs died 65 million years ago. Well, perhaps maybe it's a good thing to give you an idea what a million is all about. And we've created what is referred to as the Million Book. And what happens here is we've put 5,000 dots on each page of the book. And then we've Xeroxed 200 pages. So now if you multiply the 200 pages times the 5,000 dots per page, this gives you an idea of what a million looks like. Now, 20 books like this times the million dots would represent the amount of space debris that's colliding with the Earth each day. So 20 million little bits and pieces of rock and metal are falling to Earth each day. They don't all make meteors because they're so tiny they are completely destroyed without anyone ever knowing it. Most of the space garbage that makes contact with our atmosphere is smaller than a grain of sand. Some of the rocks and metals that get into our atmosphere are bigger, but are burned and disintegrated before they reach the surface. If they are large enough, they may be visible. They are seen as streaks of light cutting across the sky. People refer to them as falling stars, but they are really just pieces of rock or dust burning up in the Earth's atmosphere. A meteoroid is any piece of rock or metal that is traveling through space. If the meteoroid enters the Earth's atmosphere, it is referred to as a meteor. If the meteor travels through the atmosphere without burning up and makes it to the surface of a planet, it is called a meteorite. Most meteors burn up in the atmosphere because they can be speeding along at as much as 150,000 miles per hour. This is an incredibly fast speed. At that speed, it would be possible to travel across the United States in just a little over 1 minute. So when meteors traveling at extremely fast speeds make contact with the gases of the Earth's atmosphere, they heat up because of friction. Friction is caused when two objects rub together. One of the products of friction is heat. Just rub your hands together briskly for a few seconds. You can experience that heat. The meteor heats up, blows, and burns. In most cases, it will be completely destroyed by friction. However, every year about 500 meteorites may reach the Earth. Most of these land in the oceans or out-of-the-way places. Only about 150 meteorites hit the land. They range in size from pebbles to huge boulders. The largest ones can weigh many tons. In Antarctica, scientists have found many meteorites. Meteorites found in Antarctica are among the best preserved because of the cold, dry climate. Several thousand meteorites have been found in Antarctica. They are easy to spot against the snow and ice-covered surface. One type of meteorite may have come from Mars. It is possible that an asteroid crashed into Mars millions of years ago, causing material from that planet to be kicked into space. Now, millions of years later, a fragment from the surface of Mars may have landed in Antarctica. Some other interesting meteorites contain organic matter, which means that at least some substances on which life is based also exist in space. It might be hard to imagine the Earth being hit by meteorites, but all you have to do is look at our closest neighbor, the Moon. The Moon is heavily cratered. It has no atmosphere to protect it from meteoroids, and without an atmosphere, it has no weather or water. Therefore, things on the surface of the Moon stay pretty much the same. There is no eroding or weathering from wind or water, so imprints remain. Even the footprints made by astronauts over 25 years ago are still as fresh as the day they were made. The Earth is much larger than the Moon, so it is actually a bigger target than the Moon. Therefore, more meteoroids make contact with the Earth than the Moon. Our atmosphere protects us, but there is evidence of large impacts on Earth. There are about 70 huge craters found throughout the world. One of the most famous craters is in Arizona near Winslow. This crater is 3/4 of a mile across and was made within the past 50,000 years. The majority of the meteorite that made it was never found. Most of it disintegrated on impact. It was estimated to have been about 90 feet across and made up of iron and nickel. The question may arise as to the chances of being hit by a meteorite. It is felt that meteorites hit humans only once in 10,000 years. There is only one known person to have been hit by a meteorite. A woman in Alabama was bruised when a 9-pound meteorite tore through the roof of her house, hit a radio, and then hit her. This is an exhibit that has been on display in the Field Museum of Natural History in Chicago for years. It shows the sequence of events that occurred in 1938 when a baseball-sized meteorite hit a garage. It went through the roof of the garage and continued through the roof of the Model T Ford that was parked in the garage at that time. It went through the steel roof and through the car seat and floor. It came to rest on the muffler under the car. On June 30th, 1908, in Russian Siberia, there was a tremendous explosion that left an entire forest flattened. The sound of the explosion was heard 600 miles away. 5 miles away, an entire herd of reindeer were killed. Scientists believe that this tremendous destruction was caused by a meteorite or comet that burned up as it went through the Earth's atmosphere. Fortunately, this happened far from a populated area. Many scientists believe that dinosaurs died out as a result of a collision that may have occurred 65 million years ago. Traces of an element called iridium seem to suggest that a comet or meteorite of considerable size struck the Earth. Iridium is commonly found in meteorites. It does occur on Earth, but mostly near the core of the planet. Iridium traces were found in Siberia at the site of that huge explosion in 1908. Scientists have also found a thin layer of iridium in the Earth's fossil record. It dates back to the time of global extinction all over the Earth. 65 million years ago, many species of plants and animals suddenly died out, just like the dinosaurs. Scientists believe that a possible comet or meteorite exploded in the atmosphere or actually struck the surface of the planet. This explosion could have thrown huge amounts of matter into the atmosphere, causing a virtual blackout. Sunlight couldn't get through, and plants and animals died as a result. So where did asteroids, meteors, and comets come from? Scientists believe our solar system formed over 4.5 billion years ago as clouds of gas and dust began to form what would become the sun, planets, and the moons. Some of the leftover material orbits the sun in the asteroid belt between Mars and Jupiter. Asteroids are large space rocks. They were once thought to be the remains of an unformed planet that lies between the orbits of Mars and Jupiter. But that idea is being challenged because if all the asteroids were combined, they would weigh only 1/20th as much as our moon. So far, 2,500 asteroids have been identified. Some are very small, and the largest, Ceres, is 623 miles in diameter. It weighs as much as all the other asteroids combined. Asteroids could become moons of various planets if they get too close to a planet. The two moons of Mars, called Phobos and Deimos, are thought to have been asteroids before being captured by Mars' gravitational pull. Comets are objects made of frozen gases, dust, and pieces of rock that orbit the Sun in elliptical orbits. Some comets have short periods and are found in a belt that stretches from just outside the orbit of Neptune to a few hundred times the distance from the Earth to the Sun. There are possibly 100 million comets in this belt. The Hubble Space Telescope has just recently been used to spot a few of the larger comets in this belt. Much farther away, at about 50,000 times the distance between the Earth and the Sun, is the Oort cloud. This is a gigantic cloud of as many as 100 billion comets. A round trip for these comets may take thousands of years. Collision between comets cause some to move inward toward the Sun, while others are bumped out of our solar system entirely. Comets are made up of a nucleus, which is the tiny solid part of the comet. This is a dirty snowball of bits of rock and dust frozen in ice. As the comet approaches the Sun, the heat from the Sun begins to vaporize some of the material that makes up the comet. A coma is the fuzzy glowing ball that forms around the nucleus, and can grow to be more than 100,000 miles across. The tail forms when the solar wind from the Sun strikes the comet. The solar wind is a continuous stream of electrically charged particles that flow from the Sun. Because material is being blown away from the comet by the solar wind, the resulting tail always points away from the Sun and can be millions of miles long. There are two different kinds of tails that can form. A gas tail is straight and narrow, while dust tail is wide and curved. Throughout history, people have been interested in comets. In ancient times, comets were believed to be the bearers of doom and bad luck. People were terrified by them. Today, many scientists believe that it might have been comets that brought life to our planet in the first place. It is very possible that some of the water on Earth actually came from comets billions of years ago. There have been several near misses recorded by NASA over the past few years. For instance, in 1992, the asteroid Toutalis passed within 2.2 million miles from Earth. In 1991, a smaller asteroid came within 106,000 miles of Earth. This is less than half the distance between the Earth and Moon. So what are the chances that our planet will be struck again by a comet or asteroid large enough to cause mass extinction? Some scientists believe that such a collision could occur once every million years. Is there something we could do to protect our planet? Scientists have considered some possible solutions. One would involve intercepting the incoming asteroid with a nuclear warhead. The bomb would be detonated to one side of the asteroid, and the resulting explosion would cause it to change course. Perhaps this is not the best idea, since blowing up the asteroid would only make more projectiles. We can be thankful that our planet has an atmosphere that can protect us against most meteoroids. Without an atmosphere, the Earth would look like the Moon or Mercury. We should definitely keep an eye on the comets and asteroids that come sweeping past our orbit around the Sun. A big collision could cause devastating changes on Earth, and it has in the past. Perhaps most of you have heard the term UFOs. You relate those to flying saucers and unidentified flying objects, as the term describes. What I'm holding in my hand today is what we call an IFO, an identified falling object. Scientifically, these are called meteorites because they are bits and pieces of rock and metal that have actually fallen to Earth from space. The one that I have in my hand is known as a stony meteorite because for the most part, this rock contains minerals that make up rocks much like those we find here on Earth. What makes it so interesting is that there are little bits and pieces of metal mixed in with the rock. And this metal is very unusual in the sense that we don't have any of this metal here on Earth. The metal I'm speaking of is a combination of iron and nickel. Now, iron and nickel are very common metals here on Earth, but not in the way we find them in meteorites. On Earth, these two metals tend to combine with either oxygen or sulfur. But in the meteorites that come from space, they are free, for the most part, of oxygen and sulfur. So what we're having here is iron in a purely metallic form. Now, meteorites on that basis can be divided into three separate categories. Those which we call the irons, and in this case here, you can see that we have a representation of iron meteorites. They're called irons because iron makes up approximately 92% of that material. The remaining 7% is the element nickel, and then the last 1% to make 100 is an element called cobalt. In their pure form, these become very valuable metals for the manufacture of steel and other materials that we depend on for our industry here on Earth. The next group of meteorites we find in this case to my right, and these are called stony irons. Stony irons are a combination of the same kind of metal we find in the irons, but the mixture is now a 50-50. There's 50% iron and nickel to 50% of the minerals that form what we would consider to be basic stony meteorites. The big one that you see here, and we can even open the case, this particular one is known as a palisite. And this meteorite is made of a mineral called olivine, and this particular mineral, to a gemologist, is known as peridot. It's the birthstone for August. This one here is pretty badly rusted, so you don't really get to see the very nice, beautiful olivine content. We can take a look at this one here, which is a slice of this larger one. And I think it's fairly easy to see the metal reflecting nicely in the light. But these dark-looking, sort of globular features, these are representatives of the mineral olivine. And if we were to take our time and really divide up the surface area, you would find out that the shiny metal does indeed make up about 50% of the entire specimen, with these olivine crystals making up the remainder. So this is called a palisite. Now normally you would not find the meteorite looking like this. This has been cut with a diamond saw and polished to show the internal structure. But if you were to find that in the field, it would look like a rusty mass of metal like we see here. This particular one came from Brenham, Kansas, and in the 1800s, late 1800s, Indians were actually making arrowheads out of this metal. So they would hammer away the meteorite and pound out the metal into the shape of arrowheads. This is a very interesting meteorite because of its name. It's called Vaca Muerte, which means dead cow in Spanish. And most meteorites are named after the town or city that's closest to the point of find. But this particular one comes from the Atacama deserts in Chile. There's not too many cities there. As a matter of fact, there's none at all. So they name it after local features. And apparently there was the remains of a dead cow very close to where this meteorite was found. So there's a lot of local history also associated with the finding of meteorites. Now, stony meteorites do contain up to 20% of the same metal that we saw in the iron meteorites. And that metal is strongly attracted to a magnet. So if I had a magnet with me, it would stick to this rock very, very nicely. That's another indication that the meteorite is truly a meteorite. Most Earth rocks are not attracted to a magnet, but virtually all of the meteorites are. So when we look to identify a rock as a potential meteorite, we look for the blackened surface, like on Forest City here. We look for an attraction to a magnet, and then if those two are positive, then we become chemists. We actually analyze the meteorite for the presence of that nickel-iron metal. That frictional heating created sort of a shield appearance to this leading edge of the meteor. And this is what, back in the 1960s, gave the engineers who were designing our first spacecraft the shape of a heat shield to deflect the heat away from the astronauts inside the spacecraft. It was meteorites and the shape of how they entered the atmosphere that really helped our space program along. And even here, you can see on the very edge that burnt part is only on the front, and very little of that actually came over the edge of the meteorite. So we really like to find these freshly fallen meteorites. They're very, very exciting. This is a type of meteorite that's known as a carbonaceous chondrite. And what that means is that there is a certain amount of the element carbon in here, and the chondrite means that there are little BB-like inclusions that are extremely old. As a matter of fact, these little white blobs that you see here and the round inclusions are the oldest solid materials in our solar system. They have been dated, this particular meteorite, at 4.61 billion years. So there's actually nothing older in our solar system than these little bits inside the Allende meteorite. But even more exciting is what was found after the meteorite like this has been dissolved. Now, certain scientists will smash up a meteorite, grind it up to powder, and then dissolve it in acids. And when everything is dissolved away, they find little tiny bits of carbon that is actually diamond. And these diamonds were formed during the death of a red giant star that was very much older than our own sun, and at some part of our galaxy that we're not even sure where it may have come from. So there's actually little diamonds in here that come from the death of another star. So Allende is a very, very exciting meteorite in terms of the information that it holds for us. We often refer to this as the Rosetta Stone of our solar system because it gives us evidence of what the formation process of our planet was all about some 4.6, 4.5 billion years ago. So Allende is very, very famous. In this particular meteorite, we have over 40 different organic compounds. And if we were to take this meteorite apart, we would find out that 8% of this meteorite is made up of water molecules. There's been experiments where you put this meteorite on a hot plate, you heat it up, and steam actually comes out of the meteorite. And that is the same kind of water you would get from your kitchen sink at home, from the faucet. So we know that there is water in space, we know there are organic compounds in space. And on Earth, when you put water and organic compounds together, the result is life. But so far we have no direct evidence that there is any life anywhere else except on planet Earth. Some of the chemistry that's found in a carbonaceous chondrite is also very similar to what's seen in comets. Water, organic compounds, things like that. This particular meteorite came from Florida, and it was actually dragged up by a fishing net. So fishermen were out one day dragging their nets along the seafloor, I guess, and they hauled up this rock, which was later identified as a meteorite. So it's one of the more bizarre, if you will, finds of a meteorite. The most famous iron meteorite on Earth came from this location. This is known as Meteor Crater, Arizona, or as the name shows here, Barringer, after the gentleman who, in the late 1800s, established this as a meteorite impact. Prior to that time, most people thought it had something to do with volcanoes, because in the San Francisco Peaks area of northern Arizona, there is a lot of volcanic activity. In the late 1800s, people were still not comfortable with the idea that huge bits and pieces of rock and metal collide with the Earth. This is an interesting crater because some numbers have been projected for it, that if, because of its size, which is roughly 4,200 feet across and 660 feet deep, if you wanted to create a football stadium out of this, you could have the football game going on down here, and you could seat 3 million people inside of the crater. So if you wanted to charge $10 a head, you could make a lot of money with a football game here. Instead of the Rose Bowl in Pasadena, it could be the Meteor Bowl of northern Arizona. But this was created by the impact of a large mass of iron and nickel metal. We've projected that the size of the object that produced this crater was 90 feet across, and it had a mass of about 100,000 tons. So when this thing hits, it's the equivalent of something like a 100 megaton nuclear bomb. Tremendous explosion. There's a lot of material scattered around the crater, but if you were to collect all the meteorite bits that you could find and put it all together, it would add up to less than 5% of what we think the original body was. So where is the remaining 95%? Is it buried underground here somewhere? Well, the answer is no. Barringer sank a lot of shafts into the ground trying to find that nickel-iron body. He couldn't find any. Because what happens is when a large meteorite impacts the Earth, it simply vaporizes most of that body. The very high velocity impact, all that energy created when it comes to that sudden stop just simply creates heat, which vaporizes the meteorite. And this is typically what happens here on the moon. The craters that we see all over the moon are also non-meteorite producing craters. When our astronauts were on the moon and they're collecting dust and soil and samples like that, there was virtually no bits and pieces of meteorites found because the meteorites were totally destroyed on impact.